Okay, so in this question, vehicle moving along a straight horizontal road, and its speed is measured at 2 points, A and B. And at A, its speed is 12, and then at B, its speed is 20. So we can think of its initial velocity to be 12 at A, and then when it's at B, its final velocity is 20. And it says the distance of between A and B covered is 1,000 meters. Okay, so we've got that information there. Part A then says show that the acceleration of the vehicle is 0.128. So we want A. Okay, so if we know U, V and S, we can get A by using V squared equals U squared plus 2AS. Right? So V is 20, so 20 squared. U is 12, so 12 squared, plus 2 times A times 1,000 for S. Alright? So we can work these out separately if we want. That's 400, that's 144, and that will be 2,000 times A. Take the 144 over, so we're solving this. Okay, 2,000 times A, right? So that would be 256 equals 2,000 times A. And then of course you take the 2,000 down to divide to get A. And I'm going to check on my calculator, make sure I've done it right, because we know that what the answer should be. And indeed, when I check that, it comes out to be 0.128 meters per second squared as asked. Okay. So part B then says find the time taken for the vehicle to move from A to B. So we want T, don't we? Now we can use simple equation, V equals U plus AT for that one, because we know V is 20, the final velocity, we know U is 12, we know A is 0.128, okay, the answer to part A, times then T, which is what we're going to work out, alright? So take the 12 over, so it becomes 8, and that becomes 0.128 times T. So then to get T, of course, we're quite simply, we're just going to divide then, aren't we, by 0.128 to get our T. And we get, let me just check that, 62.5 seconds. Okay, so that's the answer then to part B, the time taken for the whole journey. Part C then, it says find the speed of the vehicle 25 seconds after passing A, right? So we want, don't we? We want the speed. So if we say we want V, right? So we call V our speed when T equals 25, right? Now remember, of course, the initial conditions, the question, U, the initial velocity at A is still 12, isn't it? That doesn't change, it's still gone past A at the speed of 12 meters per second, okay? It's just now, we're not interested in when it gets to B, we're interested when it's sort of part way along, when the time is 25 seconds. We also know A, of course, is 0.128, okay? So we want V then with all this information. And with that information now, you can find V. So using V equals U plus AT, okay, we can sub it in. We can do V equals 12 plus times, we want plus to me, plus AT, so plus 0.128 times the time, which is 25. So if I work that out, I get speed to be 15.2, make mistakes, yeah, meters per second. Okay, so that's the answer I get out on my calculator there. Part D then, it says calculate the distance from A of the vehicle 30 seconds after it passes A, right? So again, more information really given to us from before. We're going to use, okay, so we're now going to set T to equal 30, right? Again, remember we know U, the initial velocity is 12, we know A is 0.128, okay, so we want the distance, okay, so if we know that information there, we can get the distance using S equals UT plus half AT squared. So S will equal 12 times the time, which is 30, plus half times the acceleration was 0.128 times the time squared, which is 30 squared. So we use virtually all the equations of motion in this question so far. So I'll type that in. Okay, so I'll check I've done that right. Looks good from here on my calculator, and we get an answer out to be 417.6 meters. Okay, part E, then the final part, it says sketch a velocity time graph for the journey from A to B. Okay, so when I sketch a velocity time graph, we need to look at exactly what's gone on. Remember, we need axes labelled. Okay, time here in seconds. We need velocity there, meters per second. Okay, so we've got all the units in. And remember, let's go back to this question. Passes through A, isn't it? Speed of 12. Okay, so we put 12 there. And then, of course, it increases its speed at a uniform acceleration until it gets to 20. So if 12 was there, say 20 be about there. Okay, and we need to know, of course, the time it takes to get to B. Okay, so that answer I'm going to get from looking at my part B. And if you remember from part B, 62.5 seconds it takes to get from A to B. So we need to be 62.5 seconds along here. This is the start point. Okay, when time is 0, it's traveling at 12 meters per second. And then, of course, this is the end point. So if I draw some dotted lines up, okay, and then across from 20. Okay, you can see then, there you go, they meet up perfectly. That's the speed it gets to, up to 62.5 seconds. If we join them up, I've got a nice, simple, straightforward, isn't it? Straightforward, just constantly accelerating between points A and B. And that's basically it. That's describing this journey from A to B, where speed is increased from 12 meters per second to 20 meters per second in that time. And we got that answer out in part B, isn't it? So it's important you dig for that answer. So we include that time in our sketch.